Yeah.
That's what I heard.
Yeah, no, we're just, we give folks a few minutes to arrive since a lot of times people run late. So we are just getting started right now. Are you new to the call?
No, I'm already connected. I don't understand by a call as such, but I'm already connected to the conference and I can hear and see.
Right, but are you new to working on Istio? Would you like to introduce yourself?
My first time, so I'm just curious about what Istio can do. I already use Nginx and traffic and other proxies, and just wanted to understand what this thing is and see if I can make use of it. That's my interest.
Awesome. Awesome. Well, welcome. Thanks for joining us.
Thank you.
I posted a link in the chat if anybody's got questions or want to add to the agenda. Does anyone else want to say hi? Anybody else that's new to the call or have something you want to share?
This is Vincent. I don't have anything new. I'm just saying hi.
Hello.
Hey, the link you posted isn't showing up in the chat. At least for me, I showed up a couple minutes late.
Okay, I'll try it again.
Cool, thank you. I have one specific question, and it's maybe better followed up on the user list, but figured I'd do it anyways, which is securing non-HTTP services, so things that communicate via TCP, and specifically services that do gossip their IP address instead of a service URL. Examples being Kafka or Cassandra or something like that.
Anybody have any insight on that? Okay. So unfortunately, it looks like a lot of the core team is not able to join just yet. They're probably running late. So we can either loop back to that, or I don't know if any of the Red Hat or Pegera guys have any insight into that.
I have a request for information about new first-time users. Where do we get started in using? I would like to get that understanding. If there's a Git repo of some sorts, I'd appreciate a link. For newbies,
yeah, we can grab
not the whole product. I already know what the product is, just the newbie starting documentation.
Are you looking to start contributing code or just start using Istio?
Begin with using, begin with understanding and then using, and then eventually get to the point of contribution.
Okay.
So have you seen the docs site on istio.io?
I would go again. Maybe I missed, so I'll go there again and see if I can find something.
Well, I just pasted in the link to the release notes for the latest version.
Thank you.
So that's probably a good place to start.
Also, we're working on getting some really good sort of start from scratch onboarding documentation. So any feedback that you have with respect to that would be appreciated. What do you need to know that is not in what we already have?
Okay, so I will tell you how I think in terms of a newbie person. What I would like to, here's what I envision. I would like to say, Helm install something and get it up and running in a Kubernetes cluster that I already have. That's the kind of starting point I would like to get, like a one-liner Helm install blah. That's what I was looking for. I could not find it.
Yeah, so we do have the Helm chart support available since the 0.5 release. I'm sending you my email address. Just send me an email over there, and then I will send you all the material that you need to get started. Okay.
Thank you very much, Nilesh. Oh, you're also Nilesh. I'm also Nilesh. Oh, hi. That is funny.
Yeah, I'd also suggest checking the links that have been posted in the chat. I know there's a link to the Istio tutorial. That's probably a good one to start with.
Okay. So I got your email, Nilesh. This is funny that I'm meeting another Nilesh. But I will send you an email and let's get discussion
Yeah, and
going on.
also let me paste the chart information in the public Zoom so everyone else can also access it.
Thank you.
So just to help us understand, are you interested in install Istio using Helm, or are you interested in install your microservices using Helm?
So I think I just want to get started. So maybe begin with Helm and then more detail in terms of understanding how do we operate.
Yeah, so the reason I'm asking is the Helm install doesn't work in 06, so I would recommend you to install Istio using our YAML file. If you do want to use Helm install with Istio, you probably want to try master instead.
Okay, I'm okay trying master, and but then again, I think if not Helm, let's begin with a beginning point of a bunch of YAML files, and I can kubectl apply them or something.
Yeah, I think that probably would give you a smoother experience just because we're still active working on Helm and there's no issues on 06, unfortunately. But it should be coming very soon in the next release. Hopefully we'll fix some of these major issues with Helm.
Thank you, Linson.
Yeah, no problem.
Thanks, Lynn. Awesome. Well, for anyone else that has questions or anything that comes up, if you want to add them to the working doc, and then we can address them. We've got a couple of folks that we're going to do some demos today. First is Little Bobby Tables, which is my favorite Twitter handle name ever.
Yeah, it took some convincing of the folks at Twitter to actually give me that handle. Yeah, so I guess I could just start. I'm the guy with the blue background. So I actually have a deck and a demo that I was going to show all of you. So I guess I'm going to share my screen, and I guess we'll go from there. All right. Okay, so just so I can confirm, can everyone see my screen?
Yes.
Yes.
At least I can.
Great. So this is going to be a love story. It was originally titled Debugging SEO, but when I started writing it and started actually practicing my demos, this actually just became a love story about Istio internals. And I think knowing those and knowing how Istio kind of plays with Envoy and vice versa is also the intent of debugging. It can also help you with debugging. So we're basically just going to look using some real world scenarios at how Istio kind of propagates information to your service mesh. So real quick, my name's Bobby. People, as it was alluded, people like to call me Bobby Tables after the XKCD comic. I work at a company called Namely. We are a HR software as a service. We do payroll, benefits, and human capital management. So I've been here for about 2.5 years now. Currently, I'm leading an implementation of Istio on top of Kubernetes. We've been running Kubernetes internally for a few months now. We've built tools against it. We've been using Istio internally since version 0.1. So pretty excited about the project. We've done a lot of code spelunking. We've learned a lot about how it actually works. So that's kind of what we're going to look at. So we're going to do a 100-meter dive into Istio and its internals, explain a little bit about the lower level kind of architecture of how it works. All of this is going to be in the context of Istio and Kubernetes. Istio can be installed to other platforms, but that's not what we're actually going to be chatting about. So, and then what we're going to do is we're actually going to follow a request through our service mesh. So a request coming into an ingress, we're actually going to follow that all the way through. And how it actually gets to an Nginx pod, as an example. Okay. So one of the things that Istio is really good at is it's really good at making you forget about Envoy. But that's also one of the things that's also almost a detriment in some cases. The abstraction over Envoy, which is the layer 7 proxy that Istio uses to create your service mesh, is so well done that you just forget it's there. So sometimes when things aren't working, it's kind of hard to know where you need to actually go and look at. Is it Istio? Is it my application? Is it Envoy? So using showing how Envoy and Istio kind of play together is the goal of how do you figure out where something has actually gone wrong. So a good example is Istio Ingress. This is, if you're familiar with the Kubernetes world, the Ingress controller is something that allows traffic into your cluster. And what Istio does is it actually starts an Envoy process to accept external traffic into your cluster. It is configured a little bit differently in sidecars, but we'll go into that in a little bit. So what Istio basically does in Kubernetes is it has a pod called an Istio Ingress, and it runs an Envoy process that is configured to retrieve ingress rules from the Kubernetes API, basically. So, and then another component of all of this is the Istio pilot component, which is listening to the Kubernetes API and refreshing a cache of actual ingress rules in its routes. So Envoy is actually retrieving these ingress rules from the pilot API every second, but that can be configured to be a little bit more than that. So it has a little bit of jitter enabled too, so you get some randomness. So really quickly, if we're looking at this diagram, starting at the top left, this is kind of the life of an ingress and how traffic kind of eventually gets to your pod. So let's say we've set up Kubernetes and Istio on example.com, and we've set up an ingress rule to go to a dashboard. What's going to happen is your Istio ingress, or rather Envoy, is going to receive this request first. And Envoy has its own cache of clusters and routes that it will determine where this request actually needs to go. So you can see after Envoy, it goes down to a set of 3 pods that are load balanced by Envoy. And what's going on kind of in the background while these requests are coming in and flowing to these pods is Envoy is actually requesting from the pilot API every second, is there any new routes? Is there any new pods I need to attach to my load balancer? And on the other side of this, the Istio pilot API is also asking the Kubernetes API every once in a while, or it has a watch that anytime a new pod or service or ingress rule is added, pilot refreshes its cache. So if you think I add an ingress rule to Kubernetes, pilot retrieves that ingress rule from Kubernetes and refreshes its cache, and then every second Envoy across your entire fleet is asking the pilot API, is there anything I need to know about? And that's kind of how Envoy is configured at a very, very high level. And I'll show this in a demo here in a minute. So what we're going to do, just to tell you what we're going to do first, is we're going to actually use the pilot APIs to actually see what Istio knows about the world. And we're going to apply a service, and we're going to watch the pilot APIs actually update its cache. We're then going to deploy a set of pods and watch pilot update. And then we're going to do the same thing with an ingress and watch pilot update again. So yeah, I guess let's just hope that the demo gods are nice to me right now. So go ahead and exit out of my keynote. I'll head over to my terminal. And just really quickly, what I have set up right now is I have Istio 0.6 running on Minikube locally. And I have some simple manifests that I'm actually going to apply, and we'll see all of the changes taking place. So if we look at my browser here, this is where I actually have my ingress listening on. And if I refresh, you can see that I'm getting a 404. And that's because the Envoy controller doesn't know any routes. It's just returning a 404 and saying, I got nothing. And if we head over to this first tab I have, this is actually the pilot API's response for all of the services that it currently knows about. And you can see that has all of the default Kubernetes services for Istio. And if we scroll down here, there's probably some for DNS, and you can see kubedns and the IP addresses associated with it. And what we're going to do is we're going to add a simple Kubernetes manifest to our cluster, and we're going to see what Istio actually does with it. So if we look at this service definition, very, very simple, called example web public. It selects an app called example. It has a port for HTTP on port 80. So if I apply this really quickly, we can do apply service.yaml. We'll see that it creates it. And then if we head back to the Istio API for pilot, you can see that it actually just got added right here. So pilot actually is fetching from this Kubernetes API anytime these updates occur and updating its internal cache. And it has no hosts because we haven't actually deployed any pods that match this service endpoint. And we can actually check that by doing kubectl get endpoints, example web public. So Kubernetes has an internal resource called endpoints, and this is where all the list of IPs for endpoints are actually kept. And this is what Istio uses to retrieve all of the IPs for a certain service endpoint within Kubernetes. So now that we have that, we can actually deploy our deployment file here. So taking a look at it really fast, it's a very simple Kubernetes deployment that installs Nginx. It does install it with an app called Label. So that means that our service endpoint for Kubernetes is going to find this really, really quickly. And we can see here, it just spins up Nginx and attaches it to port 80. So if I clear my terminal here, we actually do a kubectl apply -f deployment. We'll create our deployment. And then if we head back to our pilot API services endpoint, we can see that it's actually registering those pods as they came up. So if I refresh once, if you saw it had one, and then the other pods came up, and it just kept getting these IPs. So the other thing that Istio provides is the service discovery endpoint of that Envoy actually expects. So if we take this service key, we can actually go to /registration/ this service name. And this is all of the IPs for just this service, not the entire fleet in your Kubernetes cluster, which is nice if you want to be able to just find those IPs. So now that we have created our endpoint and we can see that Pilot's APIs have updated with those IPs, what I want to do is I actually want to switch gears over to the ingress side of this now. So we've added that endpoint, but if I refresh here, we're still getting a 404. And that's because we actually haven't told Envoy how to connect to these pods, which is what our ingress rule is actually going to be doing. So what we can do is we can actually tail the logs for the Envoy ingress. So if we do kubectl -n for Istio system namespace, -l for label equals ingress, we can get our pods. So we have one Istio ingress pod running. We can copy this name right here. And if we back up a little bit, we can do a logs on this pod. Now I'm just hitting up a little bit. So when I give it some traffic, we can see, just refreshing a few times to generate some synthetic load. These logs will pop up here in half a second. And there we go. So we can see that Envoy has received these requests, but it doesn't know what to do with them. And the easiest way that you can tell when Envoy doesn't know where to send something is looking for something called a response flag. And the default log lines for Envoy will include something after the status code. And we can see right here, this NR. I don't know if you can see where I'm highlighting, but after get HTTP 1.1.404, there's this NR. And that's Envoy's logging flag for saying there's no route. So automatically we know that Envoy received the request, but it doesn't know a route for it. So we need to give it one. So now what we can do is we can actually go ahead and add our actual ingress here. But the first thing that we can do, or another thing that we can do, pardon me, is we can actually find the Istio node ID to actually get what routes does it think it has. So we can do this by execing inside of this pod, that name that I had right there. We can do a PSX. Now what Envoy, or what Istio does, is it actually starts Envoy with a flag indicating the node ID. Now, inside of this very, very long command right here, you'll see this -- service node. And what we can do is we can highlight this name right here. It goes all the way down, wraps around. We can copy this. And what we can do is we can actually go look at the routes for this specific node. So if we go back to the Istio pilot API, we can actually go to /routes/80. And if we go to the service or the cluster name Istio ingress and then paste in our node ID, we can see that there's no routes. So we've proven what Envoy's already told us, that it doesn't have any routes to actually apply anything to. So what we can do now is we can apply our ingress and we can watch Istio actually update this route table. So I have a very simple ingress here. I can do cat ingress, and we can see that it has a name of example public. And we can see that it has some very simple pathings. It's going to route everything that it gets. This annotation .star is a special Istio way of indicating everything after the slash should get routed to this service. And we're routing it to our service name, example web public. So now what we can do is we can actually apply this. We can do a kubectl apply ingress. Our ingress has been added. And if we refresh our route endpoint for Istio ingress in our node, we should see that it actually has defined a route. So now we can see that, okay, it's prefix endpoint for slash. So basically anything is going to go to this cluster. Now a cluster is an Envoy term for saying a grouping of IPs for a cluster, really. So all of the services that we had, all of those different IPs are attached to this cluster. Now, the way that we can actually look at this very easily is we can actually go to the clusters endpoint. So if we go to /v1/clusters, we can go to our ingress here. And we can see that these are all of the clusters that our ingress actually knows about. So to back up a little bit, there's a route that points to a cluster. And then a cluster actually points at a set of services. So if we look here, we see this service name. And you'll notice that this is actually the same service name that we added earlier. And if we take this service name and we go to registration / and then that service name, these are the IPs that Envoy is actually going to attempt to route to. So if I've done all of this right, what we should be able to do now is we go back to our little ingress endpoint here, the port 32,000, refresh, and we get Nginx. So this is exactly how Envoy and Ingress have played together, is that we gave it, hey, we have this route, it goes to this service. Here are all of the IPs for that service, and then Envoy knows how to route to those individual pods. And one thing that we can do now, again, is that we can actually go look at our logs for the ingress. And you can see here that we no longer have a flag. It's a response of 200 with a dash indicating no response flags returned at all. So everything seems to be wired up correctly and firing away just fine. Great. So now what we can do is let's go back to my slides.
Can I raise one quick question? Just
sure, go for it.
The pilot API, is there any specific configuration that we need to do to make that REST interface available, or as soon as it's installed, it should be available?
It should be available if you're following all of the installation steps that Istio provides on its website. As long as you have Istio, well, I mean, another way to say this is that Istio won't work at all unless pilot is running. So when you apply the Istio manifest from Istio's website, it'll include pilot and the ingress controller and the mixer, and all of that will be installed automatically for you.
Yeah, so you essentially access your pilot through the node port, right, which is enabled by default through Istio pilot. Actually, it's not. Did you actually have to enable node
I modified it.
Okay, that's why. Okay, yeah, so I was just looking at my Kubernetes install with Istio. So that's a little thing you have to do. So you have two choices. One is you can expose your Istio pilot service as a node port in Minikube environment. Or if you are running Kubernetes has load balancer service type support, so you can expose it as a load balancer service. Then you can just access through that. Can I ask a question about mutual TLS? Is your environment has mutual TLS enabled or disabled?
Currently, it does not have mutual TLS enabled now.
Okay. Because I was thinking to access pilot, you may need to have it disabled. Yeah. So
yeah,
that's
correct.
to answer your question. Yeah.
Yeah, to be able to demo the pilot API, I have modified the default installation just a smidge. I have exposed the pilot API through a node port on my local install, and that's mostly just so I can access it via Chrome really easily for demonstration purposes. I should have prefixed that. Sorry, everyone.
Oh, no, that makes perfect sense. Thank you for clarifying that.
Yeah. Okay, great. If there's no more questions, I can move on to the next piece of this. Okay, that was enough awkward silence for me. Let's keep going. So this is great and all, and we saw the traffic actually go from our ingress into an Nginx pod. But the thing that we're kind of missing here was, how did that pod even get that traffic? If you're coming from Kubernetes and Kubernetes services, the way that works is Kubernetes has a virtual IP, and Kubernetes will actually route your traffic using the Kubernetes service layer. But Envoy is a little bit different. What it does is it'll pick from a set of IPs for its cluster and then just go straight to that IP. And this is a little important as a distinction, because now that pod is receiving traffic directly from another Envoy instance. So it's going to receive a request, find an upstream endpoint to forward a request to. And then Envoy is going to using one of its many load balancer algorithms. I think it has 3 currently. The default is round robin, but you can configure that within Istio. And once a pod IP is actually selected, the next step actually happens. So if you've probably heard this term a bunch, the Istio sidecar. So what actually this means is, when you're using Istio and Kubernetes, your pods are going to have a sidecar attached to it. So if you think sidecar like a 3-wheeled motorcycle, that's kind of my picture, where you have like the big engine, like a little tiny little car on the side of it. That's how I think of it. And your sidecar is running another Envoy instance that is configured to pull from the pilot API, the same exact way that the ingress that we saw was working, where it's hitting that pilot API and refreshing its routes. This sidecar receives all traffic, though. This is kind of another interesting distinction. So any traffic that's being sent to your pod is actually using a NAT table. So everything is actually getting sent to port 15,001 technically, and then that's actually, Envoy is actually then forwarding that traffic into your actual endpoint. So really important thing to just keep in mind, I'll say it again, Envoy sidecars are receiving all of your traffic. There is one way that you can make it not receive traffic, which is in the cases where you want it to go around Envoy, not for the scope of this talk though. So the Envoy sidecar, continuing on a little bit, Envoy accepts the connection on port 15,001, and then it looks for something that's called a listener that has been configured. The pilot API also gives these sidecars a list of listeners that Envoy should create internally. So for a given sidecar, pilot will return a listener for the IP and port for Envoy to actually forward that request to. So you can actually think there's basically envoys talking to envoys, and then they're just kind of gradually, just very gracefully giving the request to whatever it actually cares about. So using this diagram, starting on the left, a request comes into our ingress, which, as we just saw, is just an Envoy binary running. And then what Envoy does is it finds from the pool of IPs an IP to connect to. And that IP actually has an Envoy running as well. That's intercepting all requests, or all traffic, really. So that Envoy sidecar, what it then does is says, oh, I have a listener for the port and the IP that you're attempting to connect to. I'm going to forward this traffic into that process. In our case, Nginx, listening on port 80. So kind of doing another quick demo, what we're going to do is we're going to look at Envoy and how it listens for traffic by looking at the pilot LDS endpoint, which is the listener discovery service. What we'll do is we'll refresh our ingress a few times to generate some traffic, and we'll see how Envoy logs this traffic to the pod. All right, quickly looking at my notes here. Okay. So let me jump out of there. So what we need to do is we need to grab the node ID of an Nginx pod that's running really quickly. We can do this again just by using that PSX. That's the quickest way that I've found to do it. But if we do a get pod, we have our 3 Nginx deployments running right here. They've been running for about 21 minutes. If I actually grab one of these, I can exec psx, run this. I want to run that somewhere else. I meant to run that in the Istio proxy container. There we go. So now we actually have, if we look here, we can see that Envoy is just another process running inside of this box. And we have our service node identifier here. So we can grab this long string. And now what we can do is we can go back to the pilot API and we can go to the listeners endpoint. So we can go to listeners / Istio ingress, which is the name of our node, or the name of our cluster, I'm sorry. And if we hit this, then we'll actually find all of the listeners that Envoy is currently configured to use. Now, the first one I mentioned at the beginning of this segment, where all traffic is being received on port 15,001. So you can see this very, very first listener that Envoy has, or that pilot has registered here, is the address 15,001. And what we're doing is we're telling Envoy, yes, bind this to a port. Open up port 15,001 to accept traffic on Envoy. And then what we're saying is use the original destination. So if you're making a request to this Envoy that was originally intended for port 80, what Envoy will do is it'll say, oh, I received your request on port 15,001, but you actually wanted port 80. So that's where I'm going to send this traffic to. And if we scroll down here all the way at the bottom, there's a bunch of listeners because there's all types of things that Envoy needs to care about. If we scroll all the way down to the bottom here, we should see our endpoints that we care about. So the service IP, or the pod IP in our case, is 172.17.0.14. So you can see that this is just another address that Envoy is currently listening for. And you can see that it actually goes through and adds a bunch of, it adds this internal route as well. So it says, oh, there's a prefix for it, and it's going to go into port 80. And then you can it also adds all of the filters as well, such as Mixer, and a few others that if you were to enable custom filters, but out of scope for this demonstration. So we know that Envoy is actually receiving traffic on, scroll too far. We know that Envoy is actually receiving traffic for this address on this port now. And we know that we have this node as well. So this is actually a really good way to just kind of figure out what is the state of the world for Istio and Pilot. So what we can do now is we can actually just tail the logs of this pod. So we can actually do a kubectl tail, or I'm sorry, I keep saying tail. What I meant to say is logs, and we're going to follow. And we're going to actually follow that pod name. So we're going to do kubectl, sorry, here, PD, and then we're going to use the pod name. And we're actually going to listen to the Istio proxy container. So one thing to keep in mind is when you're using Istio, you're always going to have however many containers your deployment has +1. And that +1 is that sidecar. So we're looking at our logs for the proxy, that Envoy proxy that has been attached to our Nginx pod. And if I just refresh this page a little bit more for welcome to Nginx, eventually, because there's only 3, it'll get some traffic. And you can see here that it actually received some traffic, and it responded with a 304 for my browser and my IP. And here is the IP of the actual, the original, where it received the request. And then this is where it's actually sending the request. So the very end of this log line is where it's actually going to, its forward destination. In our case, port 80 for Nginx. So that's kind of how that traffic gets here. So let's recap. So we have an Istio ingress, which is running Envoy. And then Envoy knows about all of the other endpoints that it needs to serve traffic to for a certain host and prefix, route prefix. So Envoy says, okay, I just received this request. I'm going to pick one of these 3 pods that I know about, and then it'll send that traffic to that pod. And that pod has Envoy intercepting all traffic. So Envoy on the other side of the world says, oh, okay, I've just received a request. It's for this IP and for this port. I'm going to then forward now to this next upstream, which is Nginx in our case. So that's kind of the life cycle of a request through an Envoy Istio mesh. Okay. Play. So I do have one more piece, unless I'm going to get kicked off the mic. If anyone has any questions, the next piece is like 3 minutes, maybe tops.
I'm curious if you ever get observability working with your example. I don't know if you're going to cover that or not.
No, we have Jaeger in production, but we're not. I don't have an actual like stats-C endpoint or anything set up for this case.
Okay.
Maybe that'll be a follow-up if you'll have me back. But yeah, so another great thing about Istio is it does add observability for free, because all of your requests are going to these envoys and they're intercepting all of your traffic. That actually means that you can get free metrics and observability without having to modify any application code, which is a huge win and one of the biggest reasons that we actually have gone with this control plane for Envoy.
Yeah, the only reason I ask is I personally have trouble to get it working with Nginx, so just curious if you went that far.
Oh yeah, no, we have it running in production. So maybe if you want to talk to me, Linsun, at some other time, I can show you that.
Okay, yeah, I was just curious for Nginx. I got the other example working. I'll catch up with you offline. Thanks.
Cool. Yeah, sure. All right, let's do the last piece. So one of the things that we found very, very helpful when we're trying to figure out what Envoy's state of the world is when working with Istio is Envoy actually has an admin page that you can actually access. And this is great because it'll actually show you the information that Istio has actually provided you or provided to Envoy. Because remember, Envoy is actually sitting there, and every second or two, it's hitting the Istio pilot API and retrieving new information. But if something breaks in the middle and you don't know why, and you just kind of want to know what the state of the world is that Envoy knows about, you can actually boot up this admin page. So what we can do is we can actually port forward using kubectl to actually see this page for our Nginx pod. So let's go ahead and do that. Exit out of here. And what we're going to do is we're going to do, using that pod name that I had, we're going to do a kubectl port forward, pasting in that deployment name. And then I'm going to forward 15,000. So the default port for the Envoy admin is port 15,000. So if I come in here now, I can actually go to port 15,000 on my local host. And this is just a very simple, back to the 1990s design page of Envoy. So we can actually look at the routes to get started. And we can see that Istio Pilot API has provided a set of routes that Envoy actually knows about, which is great. This is exactly what we want to see when you're actually adding in these routes and everything. You want to see this page have your route. If this page does not have your route, it's not going to work. Nothing will be able to get to it. Envoy won't know what to do with that route. So that's actually where you'll start to see something like a 503 or a 404. The other thing that's helpful to see is that if you click on clusters, this is where Envoy spits out all of the IPs and the service names that it actually knows about. So we can see in here that we have, let me scroll down and find it. We have the example web public. And then over here, we can see that this is an IP that it actually knows about. And what's kind of cool here is it actually has a little bit of stats and some simple statistics about this actual pod and its IP. So we can see that it has 0 connections active, 0 requests active, but had maybe some success at some point. So this is actually a very helpful page to know inside of Envoy to just understand what it knows about the world. Because it is possible, albeit unlikely, that Pilot knows the state of the world and Envoy has a different view of the world because it just hasn't converged yet. Because Envoy actually works on an eventually consistent model, and that's where that polling hitting the Pilot API actually comes into play. So if something isn't working, it's possible that Envoy just doesn't even know about it. So this is a really, really good place to go and look for it if you can't figure it out. It can also toggle like things like logging level, which is really nice. So when your pods are actually receiving requests, you can turn on different levels of logs and get a lot more output from Envoy, which is very helpful. So yeah, that's all I have. Let me close up really quickly here, and then we can take any questions or move on to other things. So go when something is wrong. Honestly, the best place to go is your pilot logs. If pilot doesn't know something, and because it's the source of truth, things are going to break. If pilot needs to be restarted, we found that when things are just, we can't figure something out, we've actually been able to just restart pilot and things tend to come back very, very effectively. That's not a great solution. We would like to know a little bit more about what is going on and why there's sometimes a difference in the world. But for now, we've noticed that restarting pilot seems to be a harmless action. We can just do that and fix problems. So one thing that I'll close up with is we've really had a good time playing with Istio. The statistics, observability of it, the meshing, the control plane for Envoy that it provides is actually very, very good. It provides most of the functionality that Envoy provides, because one thing to consider is that because it is a control plane for Envoy, it's possible that Envoy might have a feature that Istio does not support yet. A good example is, we found something the other day, very, very not big deal, but we couldn't configure the retry on rules for routes. So if something receives a 503, you can't tell it to not retry on a 503 or something along those lines. One thing that's kind of been hard, and this goes back to, I think, my third slide, that on Istio does such a good job, is that it kind of hides Envoy from you, which is great. That's actually kind of what you want. But it's important to keep in mind that Istio is not handling any of your traffic going into your cluster. All of the traffic is actually being done by Envoy sidecars or processes at the ingress level. And that was something that was kind of hard for us to really understand initially, especially moving from a non-service mesh mentality to a service mesh mentality. You just kind of have to remember that Envoy is the one doing all of the traffic load balancing. And Istio is just providing where things should go and answering questions that Envoy has. So Envoy might have a question, what is this service? What port should I listen on? That's where Istio actually comes into play. And yeah, that's all I have. I don't have a great ending or any fireworks or anything like that. So if anyone has any questions or anything, I'll stick around to answer them.
Okay, one question here. What's the interface between Pilot and Envoy when Pilot is pushing configuration to Envoy?
So one difference, the word that is actually a little different that I would use is pull. So what Istio Pilot does is it just provides a JSON API. And what Envoy then does is it's hitting that Pilot API. Now, the way it receives where that Pilot API is and where it should actually send these requests to is there's a JSON file that Envoy is actually started with that provides all of those endpoints.
So Envoy is pulling, basically.
Yeah, so Envoy every second or two is hitting the Pilot API and getting the known state of the world.
Yeah,
and in terms of
just a quick note, that's a current limitation of the Istio. Today, the development team is actively working on a push model. You're absolutely right. Sometimes the Envoy configuration comparing with the configuration in Pilot doesn't match. Which is also the result of the pull model, because some of the route configuration could be delivered out of sequence. So we are looking at the newer version, Envoy version 2 API, to switch to a push model.
So that push model is from Pilot to Envoy.
Right, which should be more effective, and it will be more in the right sequence order.
And what interface are you going to use there?
I believe it's gRPC. So it's being actively worked on. I don't know if anyone from the Pilot team wants to chime in a little bit more on that.
I have another question. If we end up needing a custom configuration to be pushed or pulled by or from Envoy, what's your design recommendation? say there is some sort of configuration that we want to apply to Envoy, and Envoy applies that to traffic. Is there any specific design recommendation as certain adapters that we need to implement in Envoys to take care of that new configuration?
Are you asking how do you get Istio to send the new configuration, or are you asking how do you modify Envoy to handle some custom configuration that you have?
Mainly the second, what you mentioned. So say if I want to satisfy a new type of policy that I want to apply to Envoy, which is not today supported by Istio, something like custom policy, and I want to apply that to Envoy, so Envoy can apply that to traffic. What design recommendation do you have in mind?
So you've got two options. If you can, if your traffic is HTTP, and you can implement your custom traffic feature in Lua, then Envoy has a sort of built-in filter that allows you to write Lua scripts that operate on traffic. However, in order to actually get Istio to insert that filter into the processing chain, you'll have to use this webhook that we added to Pilot that allows you to basically modify the Envoy configuration in flight. As soon as Envoy asks for it, Pilot computes it, but then hands it over to your webhook to do whatever modifications you want before it actually hands it back to Envoy.
Yeah, I believe that's a feature added to 0.6. Unfortunately, it's not very well documented.
Yeah, it's kind of a little technical escape hatch, but it is there. It's not particularly well documented, but if you look for a flag in the Pilot configuration for this webhook, then you can tell it where to look to get this thing going.
And on Envoy end, it would be a filter, as you were saying.
Yeah, so you would have to, first of all, build the filter that does the traffic management that you want to do. And then you would have to configure a webhook in order to insert that filter into the processing chain.
Yeah, just to be sure. So if you need basic traffic management capability, the right way is to use a route rule. You would only need what Spike was mentioning. If you need some customer filter that's not covered by our existing rules, because you're going a much harder routes for this.
Okay, thank you.
Well, Bobby, I want to say this is a really good demo and the walkthrough. I really appreciate it.
Oh, great! I'm glad. Yeah, it was fun to do, and we've been playing around with it a lot. So it was nice to put everything on, kind of put everything down on paper that we've learned.
Hey, Bobby, just a quick question. How many microservices are you running with Istio today in total?
So right now, I want to say we have around 30 in production. We're not the biggest microservices shop. We actually are we're in the the 5-year stage of a startup where we're breaking up a Rails monolith into smaller components. But we are using all of the transport features of Istio and Envoy. So we are we have HTTP APIs, but we also have gRPC APIs. All of our new services are all gRPC. In fact, most of our services are communicated via gRPC.
Gotcha. Cool. Thank you.
Mm-hmm. Yeah.
And what kind of QPS are you sending to the ingress?
So again, we're relatively smaller in terms of our QPS. So my number is not a great number. I mean, I can tell you, we do like 120 requests per minute to our ingress. But we also, because it is just a pod running in your cluster, you can spin up more ingresses. It is horizontally scalable.
Okay, so you're running on single ingress. You're running on single.
No, we're running I think 10 right now.
Oh, okay, cool.
Yeah, mostly because we want to have all of our availability zones to have at least one ingress.
That's amazing, actually.
So we actually just set our Istio scale deployment replicas to 10. And we've done that for all of the Istio services.
Oh, cool.
I'm not sure if I've heard like this scale of Istio use case so far. Maybe people might have done that and probably wouldn't have give the demo yet, but really, really good to see that you guys are doing it.
Yeah, cool.
And what kind of routing rules are you guys using with Istio? Are you using any of the traffic shifting ones or Canary or anything specific you want to call out?
Yeah, so we are using route rules, but for internal use cases only. We're not using them in production. It is a little bit hard with our CI/CD pipeline to use them, mostly because we're switching to Spinnaker for all of our deployments, and just kind of coordinating how you do a canary with a route rule, and then how do you delete that route rule is something that we haven't totally gone into. But we do use them for actual internal development. What we actually do is every developer, soon, we have a proof of concept that we're working on right now, is every developer has their own subdomain inside of Namely. So what we do is we actually create a route rule that for your subdomain will go to a specific pod that you're working on. So if you go to mydeveloper.namely.com, what we do is we register a route rule to actually just go to your development pods that you're actually currently developing on. And the reason this is really cool is because that means that if somebody's working on the integration environment or staging environment and they go to their domain, because that route rule doesn't apply to them, they won't actually see the work that maybe somebody is working on right now. So that's actually been something really cool that we're using with Istio route rules, is using it for development purposes internally.
And that's really awesome. Thanks for sharing.
Yeah, I was just curious, the scenario you were just mentioning, do you actually use Nginx before your Istio ingress to achieve the multiple domain for different developers?
That we do. So we actually have an Nginx pod that sits above all of our ingress. And the reason we actually have Nginx, so our topology is we have Nginx above everything. That's actually our true ingress point. And the reason we have that is because we actually have our WAF, our web application firewalls installed inside of that. And then what we do is we actually let Nginx just talk directly to Istio ingress. And inside of Nginx, we actually have a Lua script that just appends a header for whatever the subdomain is currently. And then we're able to create route rules on that very easily.
I see. That makes perfect sense. Yeah, that's a environment we are seeing and recommend to some of our customers too, to have Nginx kind of front Istio ingress. I think that's the right approach given where Envoy is today. So you mentioned route rule is mainly for dev. So what exactly you use Istio in your production environment?
We're using it primarily for observability right now. We want to use it for the canary deployments, but like I said, our CI/CD is not totally there for that, so we just kind of have that on the back burner. Spinnaker is not great at deploying random Kubernetes manifest files, so we kind of have to work around that.
Yeah, makes sense.
And for observability, what kind of plugins are you using? Are you using Prometheus or Grafana or Service Graph, or a bunch of all of them?
So we are using the StatsD endpoint actually. So we're actually sending everything to Datadog. So I was very happy to see that a Datadog handler landed in 0.6. So we actually get tagging. We actually did build something that was a Prometheus to Datadog exporter. So we actually had something that was grabbing all the Prometheus metrics that Istio and Envoy was providing and then sending it to Datadog with tagging. So that's something that we do right now. The other side of the observability is we do use the distributed tracing feature of Envoy in Istio. So we actually have Jaeger set up, and we actually have Jaeger set up to an Elastic search managed by Amazon Web Services. Amazon Web Services has an Elasticsearch thing that you can just spin up. So we just decided that's the easiest way. We don't want to manage a Cassandra cluster, so that was the easiest way to do this.
Makes sense. Thanks so much for sharing.
Sure thing.
Yeah, thanks, Bobby. This has been great. And I know we are out of time for today's meeting. So I want to thank everybody for joining. And Paul from Cisco was also going to share something, but we'll do that the next meeting. And if you've got any questions or anything else that you want to explore more, please post it to one of the message groups, or you are welcome to reach out on the working doc as well, and we'll keep an eye on that and can answer questions there too. So thanks everybody for being here. See you in a couple of weeks. Bye.
See ya.
Thanks. Thank you, Bobby. Bye.
Yeah, thank